Hello, and you are most welcome in this very, sometimes very chaotic space. Rambling today about question 6 of paper 2 of November 2022 from the department. Right, let's do it. In the diagram below, the graphs of f of x is equal to tan x. Okay, so this fella with all these beautiful asymptotes, not all of them, but two of them. And g of x is equal to 2 sine 2x. So this guy are drawn for the interval negative 180 up until 180. A 60k, okay, so that point I'm guessing. And B are 2 points of intersection of f and g. Okay. Right, write down the period of g. Okay, so how often does the wave repeat itself? We know that for the original sine graph y is equal to sine x, the period is 360 degrees. So this little 2 over here means that the period is going to be halved. So the period of g is then going to be 360 degrees divided by 2, which is 180 degrees, which you can also confirm visually. So from minus 180 to 0, we have one wave, right? And that's 180 degrees, the space of 180 degrees. And again, from 0 to 180, we have another full curve. So, yeah, so that's the first one. Then next up, calculate the value of k. So we are looking for the value of either function when the input is 60. That'll give us k. So so we are looking for g of 60, for example. In fact, the tan one is probably easier to work with, but we'll just double check with g as well. So that'll be tan of 60, which we know is root 3. So that's the value of k, and we can double check that. Double check. So k is also equal to g of 60, which would be needing a new line. So that would be 2 sine 2 times 60. Okay, so yeah, this is again something you could do in your calculator, but hey man, if you seek a life of pain, this is where it's at. Right, so just doing a bit of reduction to show that, well, sine of 120 is actually just the same as sine of 60, and sine of 60 is the same as root 3 over 2, which is root 3 as well. Okay, so we know that the value of k is root 3. Right. Okay, the next question says, tell us what the coordinates of B are. Okay, so I won't lie, when I remember this question vaguely, and I hate it when I do. I try to give myself a bit of time between choosing the questions that I'm going to look at in videos and actually making the videos about those questions so that I have time to forget. But I do unfortunately remember this question, because I remember as I was looking at it, I was like, oh my goodness, how on earth would you find B? And then it came to me. So now I need to kind of, well, ideally I'd be able to reenact, anyway, like perform that struggle again. But it occurred to me that this point is one period back. So B is one period back from A, right? And period of what? Well, either graph, the tan and the sine graph, have the same period of 180. So you can see that yeah, in one, if we look at one cycle of these two graphs existing together, if we look at it as happening between the asymptotes, there's 1, 2, 3 intersections in each cycle, and this intersection is the last one in the cycle, the same way that A is the last one in the cycle. So we then know that B is going to be 60 minus 180 degrees. That's the x-coordinate, and the y-coordinate will be exactly the same. So the coordinates of B are negative 120 and root 3 as the y-coordinate. Okay, and then the final question for now says, write down the range of 2 times gx. So if we were to take this graph and amplify it again, right? So we know that currently it's peaking at 2 and troughing at negative 2. If we then say 2 times all of the outputs of this function, then everything is going to double again. So this is going to peak at 4 and trough at negative 4. And that would be the range. So the range of 2g of x would go from a low of negative 4 and a high of positive 4. By the way, I don't know if trough is a verb, but I just made it one, and it should be proud. Right. For which values of x will g of x plus 5 minus f of x plus 5 be smaller than 0, be smaller than or equal to 0 in the interval x is equal to minus 90 and 0. Oh my goodness, what is happening? Okay, so the plus 5 just means that we're moving our graphs 5 units backwards. So this asymptote will now be at 85. By backwards I mean to the left. This will now be at minus 95. This x-intercept will now be at negative 5 degrees. This point of intersection will be at negative 55 degrees in k, and so on. So everything is moving to the left by 5 units. And we are looking for where the difference between them, okay, so in other words, we're looking for where g of x plus 5 degrees will be smaller than or equal to f of x plus 5. Oh, the degree went to the wrong place. Right, so where is f above g, or at the very worst they're intersecting, right, and we are interested in x being between minus 90 and 0, so we're looking at this space. Okay, so I'm just going to highlight the two graphs. So f is the tan guy, okay, and the sine one is this guy. Okay, and we are looking for where who is who again? Okay, so G is this guy and F is this guy. So we are looking for places where this one is above or intersecting with this one. I don't really know what is the significance of the plus 5. Like, yeah, it could be plus 20 and plus 20, or minus 700, minus 700. Like, no matter how much you move them left or right, if you're moving them by the same amount, then it's always going to look like this. So this guy is underneath this guy for these x values. Oops. Right, so for these x values, that is where this is greater than or equal to this. The output of this one is greater than or equal to the output of that one. So now the question is, where is this occurring? And honestly, I want to venture to say minus 60 degrees. And I'm just going to quickly double check that. So, oh, why is this all of a sudden so feeble? So tan of minus 60 is the same as minus tan 60, which is minus root 3, and 2 sine 2 minus 60 is the same as minus 2 sine, no, okay, I jumped the gun there, but it's going there. Let's first multiply the, so let's say this is 2 sine minus 120, which is the same as minus 2 sine 120, and we already know that, this is equal to that, so the minus and the minus, potato. Anyway, so that does confirm that this is minus 60, and I'm guessing minus k. I'm not guessing, it is, just looking at this. But I don't like lucky guesses or intuitive guesses. What would the actual maths be? I mean, I guess visually you can see that they are symmetric in the line y is equal to minus x, but it feels like overkill to go into that math. I mean, I guess at the worst you could just solve tan x is equal to that, but how could you? It's actually not a disaster because, okay, I'm going to quickly do it because I need to. So tan x is equal to 2 sine 2x. This is the same as sine x over cos x. And I can rewrite this guy as 2 sine x cos x, right? So that we're just talking about the angle x. Here we're talking about angle 2x, here we're talking about x. So just talk about one angle. Right, and that is 4 sine x cos x, right? And mind you, this is just the same as sine x times 1 over cos x. So let me rewrite this. So there's a couple of scenarios here. So either sine x is 0, right? Because then if it's 0, then this could be anything. Either these could be anything, and these two sides would be equal. So it's either that, or 1 over cos x is equal to 4 cos x, which is the same as 1 is equal to 4 cos squared x, and that gives us 1 over 4 is equal to cos squared x, and therefore cos x is equal to the positive square root of that, or the negative square root of that, which is positive a half, or cos x is, what am I doing? Negative a half, right? And so from that we have x is equal to so the ref angle for a half, cos x equal to a half, is 60. So that will be 60 plus k360, or 180 minus 60. Not 180 minus 60. Where else is positive? Fourth quadrant. So 360 minus 60. And then for the negative one, x could be second or fourth quadrant, so 180 minus 60. And third quadrant would be 180 plus 60. Right, so those would be all the possibilities. Right, and for sine x to be 0, x is any multiple of 180. So, right, because that's where we have all our x-intercept 0, 180, 360, and so on. This is both where k is some integer. Right, so if we are looking specifically in this interval between minus 90 and 90, then we get 0 over here, right? 0 times 180 will give us one of the solutions. The 60 will be in that interval, and then 240 minus 360 will give me 240 minus 360 will give me something that's too small. That'll give me minus 120. That's not in the interval I'm concerned with. So it will actually be 300 minus 360. Yes, that will give me the minus 60. Anyway, okay, so that was a very long, but I mean, I also an opportunity to look at how we would solve an equation like that. Anyway, so all this to say that yes, the intuition was correct. This point would be minus 60. Okay, well, the x-coordinate will be minus 60. So then, in conclusion, in this interval for the values between x is equal to minus 90 and 0, this guy will be below this guy for as long as x is between negative 60 and 0. And are we including the boundaries? Yes, we are, because that's where the intersections are happening. So that's where this is equal to this. Right, and that will be my answer. Have I checked the other answers? Oh my goodness, I haven't checked. Okay, let's check our answers so far. So chaotic, so chaotic. Right, first one, 180, yes. Second one, root 3, yes. Third one, minus 120 and root 3, indeed. Oh, fourth one, the range is from minus 4 to 4 inclusive. Yep. And they did, oh, okay. Never mind. I was going to say they kind of expected you to show some workings, but I just saw that you would have also gotten full marks for just the answer. But yeah, for their workings, they showed that, okay, the range of g is from minus 2 to 2. So the range of 2gx will be, double the boundary. So that is, yeah, I think that is a useful thing to write down indeed. And then for 6.4, oh, it's a disaster. Oh, ish. Okay, yeah, I see. Right. So obviously, okay, the 5 does matter. Trick question, because on this graph as it is, we know that g of x is smaller than f of x between minus 60 and 0. But if we were to move everything by 5 units to the left, then so would this point and this point, right? So if we were to then go just beyond, so this would now be at minus 5. So between minus 5 and 0, we would have this little bit happening where g is above f, which is not what we want. So my bad. I still stand by the idea that, moving the graphs left or right, this is what it will look like. It will just be in a different position on the Cartesian plane. Anyway, so this point will happen 5 units earlier, so it will be at minus 65 degrees. And so will this point will also happen 5 degrees earlier, so it will be at minus 5 degrees. Ooh. Okay, right, and that answer we agree with. Okay, cool. My bad. Right, last one. Determine the values of p for which sine x times cos x is equal to p will have exactly two real roots in the interval x is equal to minus 180 times 180. So from here to here. Okay, so what does this expression have to do with the functions we've been given? So tan x is equal to sine x over cos x. Wait, okay, no, actually. I am now thinking, okay, wait, 2 sine 2x is equal to 2 sine x cos x, which is 4 sine x cos x, right? So this might not have anything to do with anything at all. You know, I've gotten into the habit of erasing stuff and you just never know when you might need it, so let's rather not erase it, but just put it to the side for now. Okay, so we are being asked for which values of p will this equal to p have exactly two real roots. So we know that, okay, g of x is equal to that, okay, which is equal to 4p, right? And we want to know when will there be exactly two real roots. Dribblings. So I mean, instinctively I'm thinking, you know, so for instance, for, you know, p is equal to root 3, right, which is where a point like a lies, there are four x values that make that true, that make this equal to root 3 true. It happens here, it happens here, it happens here, it happens here. So if I'm looking for places where my ruler is only going to cut twice, then I'm looking here at the peaks, or I'm looking down here at the troughs. Anywhere else it's going to cut at least 4 times. Here it cuts 5 times. 1, 2, 3, 4, 5. Everywhere else is going to cut 4 times. So okay, so let's rephrase this. So we are looking for places where sine x cos x equal to p has two real roots. If we rephrase this problem so that we are looking at it in terms of g of x, we know that sine x cos x is the same as a quarter of gx, right? So that means that is the same as a quarter of p, right? So we are looking for places where okay, somehow this is messing with my brain. Yeah, so I feel like if we're looking for the places where this has two roots, it can only happen if this has two roots. Wait, what am I saying? Okay, no, right. So what I wanted to say is, no, what am I saying? This is p, sorry. Okay, so Sin x cos x is the same as a quarter of gx, because gx is 4 sin x cos x, right? And in fact, this doesn't even matter. What is more important to me is this relationship, right? Gx is equal to 4p. If we are looking for places where this equal to p has 2 real roots, then that is the same as looking for places where this has 2 real roots. G of x equal to some number only has 2 roots, and that is happening when that number, which is 4p, if that number is either the peak, and we said that the peak is happening at when y is equal to 2, right? Or when we are at the trough, which is when y is equal to -2. Yeah, so when g of x is equal to 2 or g of x is equal to -2, there are only 2 x values in this interval that make it true. It's either this x value, it's either this one or this one, right? And when g of x is equal to -2, then it's either this y value, this x value, or this x value. Whereas if you chose any other y value, if you chose y is equal to 1, right, which we can imagine maybe being somewhere here, then there are 1, 2, 3, 4 different x values that can make g of x equal to 1. Okay, so yes, so g of x equal to some number will have exactly 2 real roots if that number is either the highest can be 2 or the lowest it can be -2. So that means p is either equal to 2/4 or p is equal to -2/4, which is 1/2 or -1/2. Right? I was going to say, and we can double check this, but I don't actually know how we can double check that. And I mean, okay, we didn't even have to limit ourselves to looking at it this way, right? We could have just said, okay, so we really didn't need this. Another way we could look at it is sin x cos x is equal to p, okay. Sin x cos x is just the same as sin 1/2 x, right? Because, is that true? No. Okay, so we know that 2 sin x cos x is equal to sin 2x, right? So sin x cos x is just the same as, the half was in the wrong place, 1/2 sin 2x. Okay, I'm getting a phone call, so I need to wrap up real quick. Okay, so I've just written this in a different way, right? And we are looking for which values of p will cause us to only have exactly 2 solutions to this in the interval from -180 to 180, right? So if we were to draw this graph on that interval, right? So the sin 2x means that our period is 180. So that's going to be like this from 0 to 180, and then like this. So from -180 to 180, right? And the half means that our amplitude is 1/2. So this is positive 1/2, and the minimum is at -1/2, right? So if we are looking for places where this equation only has 2 solutions, so again, if we use our ruler, we can see that if we make p this number over here, then there are 1, 2, 3, 4 different x values in the interval that can solve this equation. So it's only going to be here at the peak where we have exactly 2 solutions, or down here. Okay, at the trough didn't quite reach, right? And so the question is, where are these minimums and maximums happening? So on my original sine graph, this peak was at 90 and 1. So now it's going to be at 45 degrees and a half, right? We've halved the amplitude. And over here, it's going to be at, where was this peak before? So it's going to be 180 degrees back from 45, right? Okay, in fact, we don't even really care about the x's, we just care about the y values, right? Because we want to know what does the y value have to be in order for this equation to only have two solutions. So it's going to be p is equal to a half, or p is equal to minus a half, which is what we got over here. Okay, very confusing explanation, but let me know if it was all that confusing. And if you have a clearer way of explaining, of course, that is so welcome here. And if you want a redo, I can attempt one. But yeah, thanks for coming along for this ride, and catch you another time for another chat. Oops.